In this video, we'll give an overview of the routing process. Routing is the process of moving packets across networks, and these packets are originally sent by a system on one network. They're received by that network's router. That router then determines where it needs to send the data, which typically involves sending the data to the router on another network. Once that router receives the information, then it can send the data inside its network. So these routing functions are typically performed by routers. That's kind of the role of the router on the network itself. But it should also be noted that routing is actually kind of a functionality that's built into the IP protocol that's also running on your client systems. So there is a little bit of routing happening on all hosts on the network itself. But the router is the device that's responsible for sending the data from one network to another network. Now, when we think of routing, we think of the internet. And with the internet, we've got all these different networks connected to one another, and each of these networks has a router on that network. And the routers are responsible for sending the data across those different networks that exist on the internet itself. Now, you may find a lot of times what happens is that when a router on, let's say, network A needs to send data over to network C, it has to first pass that data over to network B so that the router on network B can pass it over to network C. So a lot of times there may not be these direct links between these different networks that the router is responsible for routing the data between, which is how we get into those large networks in the internet, because these routers are responsible for forwarding traffic all over the place. The routers use destination addresses, and in this case, these are layer 3 destination addresses, so the IP address. So looking at our slide here, so over here, we'll say this is the source system. So it's sending data over to this destination system. So what happens is when this first system on the left-hand side generates a piece of data that needs to be delivered over to the second system, it constructs the packet, and the packet contains a layer 3 header. And in that layer 3 header is the source IP address and the destination IP address of the data, right? So that's contained in the header portion of the packet. So that packet comes up and it hits this router, and the router is then responsible for looking at the destination IP address that exists in the layer 3 header, and it compares it to what's called the routing table, which is a list of destination networks that this layer 3 device is aware of. So it compares the destination address in the packet with the different routes in its routing table. And basically it determines, do I know how to reach the destination where this packet is headed? And let's assume it does. So it would know that, oh, I've got to deliver this data out this interface so I can reach this destination system. But sometimes you may find that the router doesn't have the destination directly in its routing table, so it would send it to what we call the next hop, which would be another router, which would then route the data to that system. So routers choose the best routes using the routing table. So not only are they looking in the routing table to determine, do I have that destination network, but also if there are multiple routes to the same destination, it'll choose the best one, right? So depending on kind of what kind of protocols are running in the environment, that best one could be the most direct pathway. So a core feature of the router is the routing table, and the routing table has a set of rules that are stored in a table format for how the router is to handle information that it receives. So in the slide here, they give an example of a typical type of routing table and what it looks like. And you'll notice that there's these different columns in the routing table. So there's a destination network, there's a subnet mask, there's a gateway, an interface to send the data, and then there's a metric value. So the idea is when a packet comes into the router, let's say the packet is destined for 192.168.0.5, right? So what happens is that the router receives the packet and it says, okay, do I have a destination network of 192.168.0? So it comes through the table and it says, oh, I do. There's the 192.168.0. Let's say 0 network. it's got the subnet mask of 255.255.255.0. I need to send this data out interface number 2. So it'll then go and forward that traffic out interface number 2 to the destination itself. So these routing tables are very critical to layer 3 devices because they specify how we reach the destination. Now there's, as you saw, a number of different columns of information inside the routing table. So the first column is the destination, right? And these are all the different network IDs for networks that the router knows how to reach. But also there's a next hop column or next hop piece of information, and that is, where does this router need to send the data in order to reach the destination? So a lot of times the next hop will point to the next router in the chain of routers. Also, you saw there was an interface column which specifies which interface the router is to forward the traffic out in order to reach the destination or to reach that next hop. And then we also have the metric value, and the metric value is like a preference value for which route should be used over other routes. So if there was 2 routes to the same destination, then the best metric value would be utilized, or the route with the best metric value would be utilized. And then finally, we have the routes themselves that exist in the routing table. So each of the lines that you saw were routes that exist. So in this video, we discussed the routing concept.